Well, welcome. My name is Terrell Russell. I'm going to talk for about 8 minutes, 10 minutes about iRODS. And the point of today's talk is really about some of the Internet of Things scenarios we've been seeing the last year or so. And the title is Managing Data from the Edge to HPC. So I work at a university. I'm part of the iRODS Consortium, which is a member-driven organization. It's actually a paper organization underneath the Renaissance Computing Institute, which is one of 60 or 70 research institutes at the University of North Carolina in Chapel Hill. And so, like all good things, we need to start with a definition, make sure we're on the same place. Data management to us really is about having a policy, really about having a plan, and then about executing that plan. If you've got those two things, then you're doing a good job. Turns out that most people, most organizations, they've got the first part. They've got a plan. Maybe they don't execute it very well. Maybe it's all based on people, and that's usually not good enough. We talk about small scripts, tribal knowledge, vigilance, and hope, which is good, but it could be better. What we think should happen in terms of making something future-proof is really about automating that, right? And that's not easy. That's the hardest part. The reason this is important is because the policy matters. If you've got an organization or a project or anything really, even if you don't have a policy in place, that turns out to be a policy, right? A lack of a policy is one. When you're working by yourself, that may be where you start. As soon as you start to share, as soon as you start to do science, analyze, publish, create DOIs, get this stuff out on the internet, other people depend on your data, you've got to have a different type of policy in place. The nice thing is that we think that the solution that we bring to the table can support that model through the lifetime of what you're doing, right? And you can support it at different places at the same time depending on different projects. So this is a very high level picture, right? You've got things that are making data, and then you need to capture them and do something with it, right? It comes into your system, however your system is defined. And so we've seen a lot of use cases in the last couple of years with mostly sequencers, is the people that we're dealing with the most, but we've also got scenarios with satellites, with microscopes, all kinds of things, including sheep now. We've got an Internet of Things scenario happening where we're putting tiny computers on every animal, tracking all of that. And of course, for the last 15 years or so, we've been hearing about the V's of things that are big, right? And so the data is coming in bigger, faster, from a lot of different types of sources. Like, no kidding, right? This is kind of obvious. And that works as long as you've got really good people, kind of, until it gets too big, too fast, too much variety. So you've got to have policy around this. Policy's good. We think it should also be code, right? Not just that you have a meeting and you decide what it is that your policy is. That's good. But you should automate it. The point of this talk is that we think the most important thing now, because most people are now agreeing with the first two, right? Our point is that you've got to move that edge of where you capture it to the left. You've got to go closer to the point of creation so that you can make claims, right? If the data comes to you and you can't vouch for it yet, you don't know where it came from, you can't assert what instrument it came off of, you don't know what the settings on the laser was, then you don't really have as much as you think you did. So our point is that if you can't vouch for it and you can't trust it, you're really not much better off than having no policy at all. So the proposal here is that we think we've got a solution for this. And the point is that it's really an insurance policy kind of against all of that stuff changing. Because it will change. And if you're not addressing that from the beginning, you're going to be sad, right? So these devices, the storage, the networking, somebody's going to have a meeting and change the way that all the authentication works across the entire enterprise. And you probably weren't in that meeting, right? So this will allow this to morph and change with those decisions. So the first step really is to start to think about the system that you're building as being a unified space, right? If the devices and the sensors are publishing this data, you're capturing it, at what point, where is the edge? Like, you've got to first define something, right? Where is that? The next step is really to move that piece left. You want to go closer to the point of creation, closer to the point of generation of this data. This allows you to ingest either on-site or on the sheep or whatever, right? But the closer you are, then you can make stronger claims about what's going on. And if that's true, if you can do that, and you can extend that programmatic surface out to where the data is coming from, it allows you, it affords you the opportunity to address other things that are hard. We don't solve these hard problems for you, but by using the right platform and the right approach, you've got an opportunity to address some of these other things that are generally very, very tough problems. Right? If you need to harmonize that data coming in, they've got different formats. You need to do some massaging on the way in. You can do it earlier, then you can make a stronger claim about what you have. If you've got not very good networks going out to the sheep, well, you can address that. If you've captured it, you can wait till the network's good, you can store and forward, now you can make those claims. So the cartoon on the last couple slides is surprisingly very similar to what we've been working on with our one-pagers to try and explain this stuff. We've got these patterns that we've seen out in the wild, and one of them is the data to compute pattern. So this is generally an on-premise situation where you're going to pull the data in, make a claim about it, assert what it is. You can add metadata, you can tier it out, you can make copies, as well as tier it to the high-capacity, high-speed science machine that you've bought that's very expensive, right? Generally, that step involves a human. You got to put the job on the queue, you got to move the data in the right place, you've got to stage it. We can help do that automatically. You can write policy to handle this for you. The nice thing is that when the science is done and the results pop out of the bottom, it's still in the namespace. And you can have a very strong chain of custody and provenance between the source, which we worked hard to get into the system early, and the science that comes out the back end, right? And if it's a 50-step process, all of that can be tied together, and then you, again, can make those strong claims about what you've got. The last slide here is really an even higher level view of what we've been working on. We think that this model can capture pretty much every use case that we've heard in the last 4, 5, 6 years. Depending on what you're working on, these bits of functionality that we're working hard to make configurable and not having you to have to write all this code, because there are dark corners here, right? If you need ingest, we have a tool for that now. If you need tiering, we have a tool for that now. And it's metadata driven, right? This solution is all about annotating the data so that you can make those claims and do your science in a repeatable, functional way. Because if it's not repeatable and reproducible, it's not actually science, turns out. Down here at the bottom are these 3 patterns that we've seen, how people are using this technology. The one on the last slide, the data to compute, is on the far left. That was mostly an on-premise situation. You've got data, you need to do the science. It's a virtuous cycle, right? The one in the middle, the compute to data, is kind of the opposite. If your data is already in place and then you can't move it because it's too big, too heavy, or there's data protection rules, it's in Germany, you're not allowed to move it out of Germany, you can take the compute to the data. And again, we can organize this and do it based on policy rather than having humans be in the chain and they're very messy and they retire and all kinds of things, right? And the last one we've seen is people staging data from different storage technologies, making sure things are in sync, and that's the last one we've seen on the right, including on-premise or cloud or whatever. So in the end, by moving to the left, you can make those claims better, stronger, and you can do better science. And that's what I've got. We're over in booth 2238. We're the Renaissance Computing Institute booth, and iRODS is a project at RINC. So please come see us.